is that I reorganized the entire data set such that each of the groups has a different column for each of the tasks, and I'll show you right away what this gets us. So you see that we have the pretest data for groups 1 through 5, immediate post-test data for groups 1 through 5, and the same thing for delayed post-test. So we go and we try to define our repeated measures that way. What this gets us is still the chance to do a repeated measures with one single factor and two levels, namely the levels being immediate and delayed post-test, but then we can specify 5 different groups, which then, let me reset this, allows us to order a comparison between each of the groups in each of the testing times separately. So what we do is we take all of the pretest scores and enter them as covariates, and then we compare for group 1, testing time 1 is the immediate post-test, and then group 1, testing time 2 is the delayed post-test, and we do that successively for all of the groups. And then I'm going to leave this as is because, as you will see, this generates a lot of data, so I'm not interested in exacerbating that. I'm in fact not entirely sure what to do with some of the data that it comes out of this analysis. This was also, I tried earlier, and it's not informative. You see just simply a single line per each of the groups. It doesn't help you at all. Nothing here, and then here we can just do these and these, and then order descriptive statistics, estimates of effect size, and homogeneity tests. Okay, and we see the output. So immediately we see that here, unlike it was the case before, we're comparing times 1 and time 2 for each of the groups, which is good, is what we wanted. These are the non-adjusted means. Here's where my problem is. When I do it this way, for whatever reason, I only get 19 subjects, and that's ridiculous. 19 subjects is what I have in group 5, is my smallest group. But for whatever reason, I can't get the software to read the different number of subjects that are present in each of the different groups. So that's my problem with this analysis. Otherwise, I think this would be what we want to do. So what do we see here? We see the information about the covariate. We see that it's not significant anywhere, even though the effect sizes seem to be large, but whatever, I don't know what to make out of that. And then we have the interaction between testing time and in each of the groups, and we see that it's never significant either. Then we have sphericity, which I read in Huitama's book. It doesn't really concern us because we only have one factor and one condition in these repeated measures, so we'll leave that aside. And then we get to the part that interests us, that is the effect for testing time for each of the groups. As we can see here, nothing of significance. We see the same thing in the next table, which is in case sphericity cannot be assumed. There's different tests here, but either way, it's always negative. You never see an effect for testing time in any of the groups. So then is where it gets a bit weird, in that I don't understand why we are seeing testing time and pretest score interaction for group 1 and then comparing it to all of the groups. So I don't understand what this is. Perhaps one of you two can let me know if you know what that is. Either way, that's all fine and dandy. So it gets us that pairwise comparison, but again, we're only reading 19 people, and I don't really understand why. So I guess that is one option. I'm going to send you a second video that shows me doing the same thing but separately for each of the groups, which I'm not entirely sure if it's a problem. I mean, I don't know if I'm increasing the chance for type 1 error. So this is it though for video 1, just that 19 people problem there.